Hello. So today we will take the mock interview with our one of the student, and this will be completely based on the resume what she have written in the resume. So based on the resume, we will take the second round of the interview. So hello, yeah, we can start with the introduction once.
Hello, I am Upalpana Datta and currently I am pursuing MTech in VLSI and Embedded System from IIIT Delhi. And
Hmm.
I have uh, uh, done some many projects in verification role, and I want to express my skill and proficiency in Verilog and verification role in a industry
Mhm.
environment. And thank you for considering my.
Okay. So in your resume, there are two types of projects. Like you have work on analog layout as well as you have worked on the DV side also, design and verification side. So which profile you are targeting?
Actually, I'm targeting in uh, digital profile like verification and RTL to GDS, but I am also comfortable in analog profile or memory profile.
Okay, good. Got it. So you mentioned some of the tools like LDOS tool. Like what is the purpose of LDOS tool?
ELDO basically we have generate waveform through ELDO like in Cadence Virtuoso we first did the semantic and then we to check the functionality of the semantic we use ELDO through CIR file and .src file and .src are the netlist file and .cir file we wrote the CIR file CL script and we apply all the stimuli and what we need to generate in the waveform. All these are mentioned in the CIR file for TCL script.
Okay, that is for layout basically, right?
Yes.
Okay. Sky 30, 130, 103, Sky 103. What is this tool? Like it is all
Sky
about?
130 is an open source tool. We use this tool as a replacement of Cadence. Like we generate layout in Sky 130 and we also use we also generate waveform and to check the functionality of the semantic we use that.
Okay. There is one more tool, NG Spice. NG Spice.
NGSpice is also a simulator and it is related with Sky 130. Like for layout we use Magic in Sky 130 and with simulation we used NG Spice.
Okay, got it. There is NC Verilog. What is NC Verilog?
NC Verilog is a tool to check the coverage, code coverage or branch coverage of RTL code. It is present in the Cadence only, and for RTL to GDS Pro, we use that.
Okay. What are the other tool we can use for the same purpose?
For RTL to GDS Pro, we use several tools like in Cadence. First, we use NC Verilog for checking the code coverage. Then for synthesis, we use JNS, and then for LEC check, logical equivalence checking, we used conformal. Then we used Tempest for STA, and we used we used Innovus for no, sorry, Janus for DFT, and the whole done in Innovus.
Okay. You have mentioned OpenLAN. What is this OpenLAN tool?
OpenDelta is also RTL to GDS tool. We used a DFT scan-chain insertion for a small project, like for a functional testing of flip-flop. We use that OpenLAN, and EOSys is a SK checking tool, and this is also uh, as a open source tool.
Okay. And Gem 5 tool?
I used in a computer architecture project, and it actually we used it for cache coherency check, like how the cache latency differ and how data and cache memory is differ with the unavailability of L1 cache or L2 cache. Like
Okay. Hmm. Okay, project one. So you have written RTL to GDS flow of pin protected PPL system in Cadence. So yeah, tell me what you have done exactly in this project. What was your role, and what was the role of your teammates?
What is the role of?
What is the role of you that you have done, and what are the role of your teammates they have done? You have mentioned team of four, right?
Uh, Actually, the pin protected locker system is a system that generates that we create a FSM through RTL, and in that FSM we have shown that if password is matched and all the flag is completed, then the lock is open. And if password is doesn't match and after try of wrong password, it will lock for 5 seconds. Like it will take a whole stage. This is our main concept of the RTL, and we implement this whole the process through FSM. And I was involved in RTL coding and code coverage checking and STA checking and the PD function.
Okay, okay, fine, fine. So what do you mean by PLL? Yeah, PPL lock system, pin ported lock system.
Pin
So
protected lockers.
yeah, what is the exactly functionality of it?
Like we set a pin, predefined pin in our code, and that was hard coded. And if the code is matched, the lock will open. And if the code is not matched, the lock will not open and return again to the previous stage. And if the attempt was failed, then it will take a whole time, like
Okay,
like 5 minutes.
okay. What are the application of this plan PPL lock system?
It it can be used for a security purpose.
Security where? Like where you want? Like
Security
cyber security?
locker system basically like it's a chip for locker system. Can
Locker system. You mean cyber security can be in one of the example
no,
or
no,
not?
not
No?
cyber security, like
Then
security, like if anyone want to open any a lock with pin or a door lock or like a
you
lock
mean digital security or like
physical
digital security? Okay, 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 got it. Okay. So you have mentioned equivalent checking. What do you mean by equivalent checking?
equivalent checking, basically a formal verification method. We check the functionality of RTL is matched with our output or not.
So how it is different from formal verification? The same as a formal verification or is it different?
Uh, Basically, one type of formal verification.
Okay,
Logic
okay,
is meant or not. Check that.
okay, okay, okay. You have mentioned that you have done the DFT using Cadence tools. So what you have done in DFT part in this
In
project?
TFT, we replace all the normal flip flop with scan cell insertion flip flop,
Hmm.
and we did the changing netlist also. And after that, when we run the whole process, if uh, the all the flip flop are working or not, that we check in that whole
Hmm.
process. And we
So
also the SDK after that.
okay, okay. So you have written the code for this scan part.
No,
Okay.
we use the previous netlist that we generate in Janus, and we
Hmm.
replace all the normal flip flop with scan and insertion flip flop. And
Okay,
we use
okay, okay. Hmm. So you mentioned that you worked on the RTL part of this project PPL. So you can tell me the logic what you have used in the RTL part exactly,
this, sir.
the logic part.
Basically, it was a six-stage relay machine FSM, and first three stage we check that the predefined password is met or not. If met, then it will return back to our another stage or previous stage or any stage is failed to check, then it will return to a first stage. And if after 3 attempts, it will go to a undefined stage or a stage with no link with first stage, and it will take a hold of 5 minutes. And I can
Okay.
write
Okay. So you have taken the default password, right? You are saying default password you have taken. Okay. 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 And if we want to just reset our password, so what will be the logic for that?
this for reset after uh, for like we hard code the password, and if we want to change the password or reset that, we need one more FSM for that.
Okay. Okay. Okay.
Like
Okay.
put the password for FSM,
Hmm.
first stage, first input, second stage, second input, and first stage, third.
Hmm,
That
hmm,
was
hmm.
our plan.
Okay. So you can make the logic for that now. Okay. No need right now. Maybe in the interview they will ask the logic also. Okay. And what about the STA part? What you have done in STA about in this project? What you have
In STA, we check the slack is met or not. Like for positive slack for setup and negative slack for hold. And STA, we have done multiple time in the whole RTL to GDS process, after equivalence checking, after CTL, after routing, and after after all the DRC and LVS check. Before ECO, we also have checked STA. The timing
Hmm.
requirements are met or not, that we check. Whole validation, setup validation.
Okay, okay, okay. You have checked the setup time and hold time also? Okay, okay, got it. And in the physical design part, what you have done exactly in this project?
Physical design part, first we have done code planning, power planning, then placement, and then clock list, and then the routing. That's first part, global routing and detail routing. After that, again STA, and then um, we go for DRC, LPS, and
Okay, okay. So finally you have made the GDS file, right?
yes, sir.
So you have taken the output of that file also, like you have sent it to the foundry or like it was up to the
No,
GDS file only?
we didn't send it to Foundry. It was our course project, so we just submit that.
Okay. Mhm. Okay. And how many marks they have given out of like how many?
We got full marks.
Full marks, 200 out of 200.
Sorry,
Okay. 200 out of 200.
209, like 20 out of 20 for
Okay,
project.
okay, good. Okay, okay. Coming to the second project, you have mentioned synchronous FIFO verification in system value.
Yes.
So tell me what do you mean by FIFO?
And like we write a system FIFO code in system Verilog, and it was synchronous FIFO. Like it was made by one clock signal. The whole operation operated by one clock signal, and we check the full condition, empty condition, and the depth calculation, and we use a count pointer which is based on depth, check the empty and full condition, and after that uh, we write the RTL code of how data is transferred to pointer,
Mhm.
and after the FIFO code, we create a EPM based test bench, which is UT, and we write. Actually, I have done the project a lot. I write the uh, first I write the agent code in the system Verilog, like sequencer, driver, monitor, scoreboard, and environment test bench, all the code, and two more file I need. That was file and compile file to run and observe the waveform of the project. And after that, the project was done. And
Okay, okay. You mentioned you have checked the empty and full condition. You know about the almost empty and almost full condition, almost empty and almost empty.
Yes, almost empty, almost full. Like if one bit is left, then almost full, and if slightly different of one bit is almost full and almost empty.
So you can write the equation for that, almost empty and almost full.
I have not used that in my code, but I can apply that.
Okay, got it, got it.
Like with verbosity, like that.
Got it, got it, got it. So you have done this project verification part, right? System value. You can make the architecture of system value, test bench architecture,
Architecture of
art
system.
set test bench top architecture of system value. So yeah, just tell me the steps, basic steps you
There
follow.
was a test and
Hmm.
test environment, and there is a sequential which generates random sequence of
Hmm.
vector, and this was driven by a driver and passed through a monitor where it will test, and then it will go to a scoreboard where it will compare with the actual value and the predefined value that is stored, and all this will operate under a DUT, design under test, and after scoreboard, it will create a final result. And it has
Okay.
three stages like run stage, build stage, run stage, and final cleanup stage. And in build stage, there are four stages like build stage and connect stage, end of operation, startup simulation. After that, run stage will start, and after that cleanup stage, and in cleanup stage the final report will generate that the stage space is verified or not.
Okay. Okay. Fine. Fine. So also, yeah. Um, you have used a virtual interface or physical interface in this your
Physical interface.
physical interface you have used. Okay. In test bench architecture.
Yes, sir.
Okay. Just cross check it once. Okay. So you have done only synchronous FIFO. You have tried the asynchronous FIFO also.
I have not tried, but I know the logic. Like two clock signal will use for asynchronous FIFO, for
Hmm.
write and for read. The both operation for the both operation we use two different clock signal for
Mhm.
asynchronous FIFO, and I guess it will take less time to operate.
Okay,
But
so
the
we have the synchronous FIFO. So then what is the need of asynchronous FIFO then? What is the need of asynchronous FIFO?
I think it will reduce the operation complexity and time complexity, but
Yes.
it will take more design complexity.
Okay, just go check it once. Okay, okay. And we are using binary counter or gray code counter
Yes,
in this
I
like
know about that, like binary counter, gray counter, and hot coding encoding.
Mhm. Which counter we are using in synchronous and asynchronous, both you can tell.
For synchronous FIFO, I used binary counter.
Okay, okay. And asynchronous?
Sorry,
In asynchronous, which counter we are using?
I have not done asynchronous, but I will try it
Okay,
with
you can
hot.
check. You can check. No problem. At least the theoretical part you can know, right? What is the difference and all, right? What is the diagram of that? Why we use it? What is the need of that, right? All these things you can do. FIFO depth you already know, right? FIFO depth is simple only. But they will ask in the interview FIFO depth calculation. Okay. Next project you have mentioned as FIR filter implementation of um, FPGA board using AXIDMA. So tell me about this project, what you have done exactly, and it is
Uh,
solo project.
I have designed an RTL code and a IP intellectual property block, which is a functional block, and this has two port like ACP port and HP port, high performance port, and acceleration cache coherency port. in Vivado. The whole project have done in Vivado, and we check the execution time of PL and PS through SDK, Software Development Kit, and the RTL code. We calculate the execution time and we calculate the expedition time in that manner, and it will result that ACP port has less execution time than HP port, as it has cache equivalency property. So cache out, flash out, and it will take less time than HP.
Okay. So you have written FIR filter. What do you mean by FIR filter?
Fine. FIR filter is have data size of 30, and I use symmetric optimization, and like data have symmetry, so it will take less time.
Mhm. And
Finite,
IR filter? What is
uh,
the difference between FIR and
finite,
IIR filter?
finite and infinite. There is difference, and FIR filter and IIR.
Okay, so which is better and for what purpose?
Uh, I used FIR like IIR filter was more difficult to handle, I guess.
Okay, okay. Just cross check it once, fine. Okay. So which FPGA board you have used in your project?
We used ARM Cortex 9 FPGA board,
Okay, okay,
which
fine.
uses AXI, which was based on AXI protocol.
Okay, 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 okay. Hmm. What are the different, tell me three companies that provide the FPGA board or any three board of FPGA?
Like HB, AXI, or APB protocol different.
No, no, board, FPGA boards. I'm telling you. What are the different FPGA boards name?
ARM, AMD FPGA board are also available, I guess.
Okay, just cross check this question also. Uh, okay. So you have done the like hard software implementation of this project, right? FIR filter. So what are the code you have used? Like for which coding you have used?
RTL code in a very long,
Very low
and
only.
done in
So
Vivado through SDK.
Vivado SDK. Okay, okay. Then you have imported in like
Yes.
in FPGA board, right? Okay, tell me about the FPGA cycle, design cycle of FPGA.
Programming logic array. It is actually uh, 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 in ASIC design. The constraint are there is constraint, like it will not programmable at any time, but FPGA board can programmable at any time. It is multi-purpose board actually, and low power consumption.
I'm saying what are the FPGA flow cycle? Flow cycle you can tell. What are the
Okay,
steps?
FPGA flow cycle, which is high level synthesis flow cycle. First, we create IP in Vivado, and then we create bitstream generation, and that bitstream is loaded to FPGA board, and we write RTL code in SDK and run it uh, with GP port in SDK, and after that we can perform the whole logic and have in the
Okay, just cross check it once also, right? Okay. Uh, you mentioned as a uh, ACP, accelerator coherency port, right? And HP, high performance port. So what do you mean by all these ports?
high performance port actually have the both port have
So these are
pipeline.
the port in FPGA or like what?
These are
Where?
the port in FPGA.
Okay, okay.
These
So
are the
what do
port
you
in
mean by
FPGA.
yeah?
We can
So
access it through Verilog and through Verilog library.
okay, okay, okay. So what do you mean by both like coherency? What is the functionality of both?
Port actually connect DMA with GDR, direct memory access with DRAM, and this ACP port has a advantage that is has cache coherency property that flash out the cache storage and the execution time will less. And HP port is high performance port, but it does not support cache coherency.
Okay, okay. So also, how to reset the you said FPGA is programmable. So how to control the FPGA, how you will control the FPGA board, like
By physical board, we can reset it through reset button in the board only.
reset button is there. Or if you want to do some changes in the existing, like you have done the code, like you have imported everything. So if you want to do the some changes in the existing code, so how you will do it?
Stop the execution that time and change the code, and after that board system VSP will again generate, and
Mhm.
after that we can run the code again
Okay.
after
Okay, you have to do it again, import your code again. Okay, okay, got it. So next project you have done schematic and layout of two input NAND gate, right? So what you have done in exactly in this?
this was a project, and I have also done the project in Cadence only. I have done the sizing of NAND gate through CMOS like PMOS and NMOS, and have observed the functionality in LO and generate the layout and check the DRC and LS. And also I have run the Monte Carlo simulation through CIR file with .n and 500
Okay, which tool you have used? Which tool you have used in this project? Which tool you have used?
cadence, cadence LO.
Eldo. Cadence is okay, fine. And what do you mean by Monte Carlo simulation? What do you mean by?
Monte Carlo is a statistical variation uh, tool. Like by this, we iteratively run the the simulation and generate a histogram waveform. And
Hmm,
after that, we generate a mean and deviation. Then uh,
hmm.
uh, our expected output, how much deviate from actual output.
Okay, okay, okay. So you also said in your resume that you calculated the resistance and sizing and power
Yes.
and delay calculation. So how you have done it? Power and delay calculation.
Sizing, we uh, we
W
follow
by
the
L
method
ratio.
of basic inverter sizing like PMOS
Hmm.
for 2 and NMOS for 1. With equivalent of this sizing, we try to size the whole NMOS CMOS circuit, and the gate length it was 65 nanometer.
Hmm.
Ratio is PMOS was 2 and 2 and NMOS was 1 and 1.
Hmm. Hmm, hmm. So you have written PVT condition. What is by PVT condition? What do you mean by PVT condition?
Process variation temperature, process like fast, fast, slow, slow. We have checked all this corner, and for voltage,
So it's you said you have checked the slope of input and output.
yes,
So what is a curve like x-axis and y-axis? What is a value? What is a
the curve
very
was like VTC curve, input and output, it will like this,
it is VT curve.
VT curve.
VT curve. Okay. And what why you are taking like temperature as a like
Because
parameter?
temperature, because a threshold voltage is also depend on temperature, and it
Okay.
will vary the delay
Okay.
and
You
increase
can
current.
okay. You can tell me how it is threshold voltage is dependent on the temperature, and you can write the full equation also
And
of threshold
yes, sir,
voltage.
for if temperature increase, then delay will less, and VT will also less. But uh, uh, there is a function, and there is a term that is temperature inversion. Like VT is increased after certain point, VT is also after a certain point of temperature, visibility is also increased.
Okay, you can tell me the rough curve that you have got in your project. Like roughly, you can tell me the
And
curve shape.
heat is inversely proportional with temperature.
Okay, tell me the rough curve you have got it in your project.
This is it visible?
Little bit visible. Okay, okay. Okay, fine. From next time you can use a better camera actually. This time it was not good. Okay, no problem. So what was the result of this? Like it is for the calculation of power and delay only, right? This project and using like a layout, right? Okay, got it. Next project is implementation of Domino's style AOI 221. What is this project about?
So one that is reconstruct the gate with two input, again two input, and again one input. And I use domino logic in to which is different from CMOS logic by the number of transistor and by the number of clock gate. In CMOS logic, we need to if n number of input we need, then we need to n number of transistor. But in domino logic, we need n plus 2 number of transistors, like n number of MOSFET and two PMOS. One PMOS
Okay,
for clock and one PMOS for charge shipping.
okay. What do you mean by domino style? What is the mean by?
This is generated from dynamic logic, and it drastically reduces the number of transistor and area.
Okay. So this is already existing style.
Yes, it's already.
What are the different styles you have heard about? You
Sorry,
have any,
repeat.
you have heard about other different styles also, like similar
Yes,
to this? Yeah, tell me the name of the styles.
for like a static and dynamic difference.
Yeah.
In static, there are more power consumption is there, but in dynamic, there is less power consumption. Number of
Hmm,
transistor is less, area is less, which will uh, uh, these are all the advantage, but one disadvantage is there is charge keeping is bit difficult in domino logic. So for charge keeping, we use the extra PMOS, and cascading was a problem. And for that, we used a NOT gate and or an inverter with the logic.
Okay. And you mentioned that standard cell 13T layout. What do you mean by it?
10T basically a sizing method. By 10T, we use the height of the layout, and 1T means the gap between two metal layers.
Okay. Got it. You have analyzed the same power and delay in the same. It is almost like previous project, right? Okay. What was the curve in that? What was the curve you have got in that in this domino style AIO 1221 project?
So if we have seen delays and power,
So tell me the curve shape of the curve. It is similar only, like or different?
similar functionality test only.
Okay. Mm. Oh, what do you mean by AIO? AOI, sorry, AOI.
Or inverter logic
Or inverter logic.
and or inverter.
Okay. There is other terminologies also.
OAI or and inverter logic.
Okay, what is difference between both?
Uh, in AOI logic, first we use AND gate, then OR gate, then inverter. And in OAI logic, first we use OR gate, then AND gate, then inverter. But the input is same.
Okay.
If
Can
one
we do a I also? IAO or
no
IOA?
IAO not possible.
Why it is not possible?
IAO possible, but then we should choose the input number of input more specifically, or more number of inverter we need.
Okay, okay. Okay, fine. Coming to the next project, RIX 5 project pipelining, stage of pipelining, RTL designing. So what you have done in exactly in this project? And this
This
is a team mate of 5. Okay, team size is 5. Okay, tell me about this project first.
project is basically on the RTL design, and I have write the execution portion RTL code. In execution portion, I write the ALU part and load store all the execution part. It was a pipeline based RTL code. In pipeline based RTL code, there are 5 stages like fetching, decoding, execution, memory write back. And in execution, after decoding the operation, we perform the ALU operation like subtraction, addition, multiplication, register, and we use node store NOC and stalling bypassing also. If one instruction is executed early, then we pass the data in through bypass in execution stage to extra register, and all and we use multiple register for all these operations.
Okay, okay. For the stage pipeline. What do you mean by RIX 5? Why we are calling as 5 only, like 5V?
Sorry?
RIX 5, what do you mean by RIX 5 processor?
RIX 5 actually reduce instruction based pipeline based structure architecture, and 5 indicate that it has 5 pipeline stages.
Okay, it is possible that we use using 3 also, 3
Yes, that
3
is
pipeline.
possible.
Okay, okay. Then what are the steps for 3 pipelining?
3 pipeline fetching, decoding, and execution.
Okay, okay, okay. 2 is possible, 2? 2 is possible?
Without
So,
execution, it's not.
okay, got it. You have done branch prediction and bypassing. So, what you have done exactly in this?
In branch prediction, I perform that branch is taken or not, and for this, we write a different module and instantiate that in main code. Branch prediction was not saturating. If there was a flag, branch taken flag, if branch is taken, the flag will be 1, and if branch is not taken, the flag will be 0. And after that, it will show the Vivado simulator this branch is taken or not. If branch is taken, then all the execution program counter will increase by 1, and all the execution was flash up.
Okay, okay, got it, got it. So you have implemented this program using Verilog only.
Yes, sir. Very
Vivado only, Vivado.
good.
Any other tool you have used in this project? Any other tool?
No other.
Okay. You have designed also load NOC and store NOC. What do you mean by all these things?
Load NOC and store NOC. Load NOC basically load a particular value in particular address, and all the whole thing is to have done with program counter flag.
Hmm.
Store NOC, in store NOC program there is a value in immediate value which will add with the address and store a particular different address. This operation
Okay.
is done with load NOC.
What do you mean by NOC then?
No operation change.
Okay, okay. Design using no operation change. What are the other things you have designing this? Like any other thing you have mentioned, you have not mentioned in the resume? Have you designed it? Okay, what was the objective of this like RIX 5 processor of making it? Like what was the output of that basically?
Implement the instruction for architect.
Okay. What are the inputs you have given in this? What are the inputs you have given?
I gave an input of binary file and opcode file, instruction file. In instruction file, we mentioned all the instruction like subtraction, addition, multiplication, branch instruction, NOC instruction, all the instruction set, and generate opcode based on that instruction. And we mentioned that opcode in our RTL code only, and comparing this file, one two txt file, the Vivado simulation will done.
Okay, got it. Okay, coming to the next project, 6T modified SRAM. So what do you mean by 6T modified SRAM?
In 60 modified, it's basically it is a 60 SRAM. The word modified is used because we use the transmission gate instead of one NMOS connected to bitline, and we remove the PMOS from the pull-up network.
Okay,
That's
60 means
6 transistor are used for pull-down circuit, 4 NMOS and 2 NMOS and transmission gate 2 NMOS
okay,
and 2 transmission gate are used with bitline.
okay,
But
okay, okay.
bitline card.
You mentioned you have calculated the FOM. FOM used in different power and voltage conditions. So what do you mean by FOM?
The figure of merits, I test right margin and SNM, static noise margin, and one more FOM, leakage power.
Okay, which logic family have the list FOM and what is the advantage of that?
Static margin, I got the list value, and it can flip the data as early as possible, and it will improve in 60 modified and 60 normal static SRAM.
In logic family also there is FOM, right? Logic families, if you
Yes.
remember in digital. So which logic family have the list FOM?
NAND.
NAND. Okay. Okay, just cross check it once. Okay. You have done the pre-layout and post-layout. Both operations were done. So what you have done in post-layout and pre-layout operations?
SNM was slightly increased, but it will not affecting right margin.
Okay, okay, okay. So basically, you have done the analysis of pre-layout parameters and of post-layout parameters.
Like
So
it was increased because of parasitic capacitance.
okay, okay, okay. So what? How was the changes were there? Like how many like data was matching before the layout and how much data was matching after the layout?
It was fully matched in both the cases.
Both the cases it was fully matched. So okay, you have done some changes also for getting the fully matched after the post.
Sir,
Or
we have not done much changes. Just SNM value and right margin value we have observed, and it will all the values will slightly increase.
okay, so it was dependent on W by L ratio also.
Yes, and W by
Okay, so based on the W by L ratio, you can change the layout also.
yes, sir.
And W by L ratio affects the power also according to you.
Yes, power it will affect.
Okay, got it, got it. So it will affect the static power or dynamic power or both.
W by L ratio affect static power.
Static power. Okay, just cross check it once. Okay, last project is you have done alpha type sensor amplifier, sense amplifier. So what do you meant by this? And you have done the three as a team. So what was your role and what was the teammates' role?
Sorry.
Last project you have done alpha type sense amplifier. What do you mean by this project? M plus. Yeah.
The sense amplifier, which was which measure the difference between a bitline and bitline bar voltage. Amplify the difference between bitline and bitline bar voltage to identify the read value.
Okay, okay. Have you not like design other amplifiers? Any other amplifier you have designed?
No, sir.
Like operational amplifier you have designed? No? Okay, okay. So you have used like two tools in this, like Cadence Virtuoso and Eldos tool. So what was the like functionality of both? Like what for what purpose you have used both? You can tell me individually.
Semantic and Eldo for checking waveform, and again Virtuoso for layout.
Okay, okay. Similar things you have done like F1 calculation in different post layout and post pre layout. So okay, okay. So what do you mean by alpha type sense amplifier? You can tell me more about this.
Conventional sense amplifier, there is differential amplifier, and
Hmm.
the cross coupled inverter was there. In alpha type, we add a pre-charge circuit and we add a equalizer circuit. In pre-charge circuit, it acts to charge the bit line to VDD or up to VDD or VDD by 2.
Mhm.
And the
So,
equalizer circuit maintains the voltage value of bit line and bit line bar
mhm.
to perform the
So
output.
okay, okay. What is it amplifying? Like what is the input and output? What is it as amplifying?
Difference of voltage between bit line and bit line bar. Uh,
So
the,
voltage it is amplifying.
yes,
Okay, can we amplify current also?
sorry.
Current and power. Can we amplify the current also in this?
Uh,
Amplify the current.
no, sir. This is voltage control amplifier.
Okay, voltage. Okay, okay, okay. Okay, what was the exact result of this? Like what was the objective of designing this project?
First, functionality check, then sizing and area optimization, and
Hmm.
less delay. These are
Hmm.
the objectives. And we
Okay.
have run a common central layout
Common central layout.
to reject noise, and we use a guard ring in
Okay.
layout
Okay.
from
Okay. Mhm.
reject parasitic noise.
Parasitic noise. So, what do you mean by parasitic noise and how
The
it is
noise
calculated?
that create the noise created through capacitance and substrate material like P diffusion layer and poly.
Mm. Okay, okay, okay. What is the formula? You know the formula also?
And
No. Okay, okay, fine, fine. Um, what are the other type of the noise in the electronics? You know about any other noises? You know about short noise or short noise? SHOT, short noise, thermal noise. Okay, okay, you can go through these terms also. Okay. Mm, okay, these are all the projects, but you are applying for the designing part, but almost all the projects are from layout. So where are the protocol based projects?
sir, one FPGA based project, one RTL based project,
Hmm.
two RTL based project.
Add more projects in this resume. This is like based on the like layout, more oriented towards layout and memory designing. So try to add some AMBA, I2C, SPI also, all those projects, right? Or
Yes,
you
sir.
can make two resume also if according to you are applying for the digital role or like layout role, right? You can make the two resume also. Oh, fine. So any questions have or can we stop the meeting?
UVM FIFO UVM से क्या क्या क्वेश्चन आ सकते हैं इंटरव्यू?
तो क्या क्या पूछा आपने?
FIFO UVM से क्या क्या क्वेश्चन आ सकते हैं इंटरव्यू में? कोड लिखने के लिए आ सकते हैं क्या?
कोड छोटा छोटा सेगमेंट्स लिखवा सकते हैं, छोटा छोटा
मतलब
सेगमेंट्स।
स्कोर बोर्ड और मॉनिटर एजेंट ड्राइवर।
एग्जैक्टली वही सब छोटा कोड से लिखवा सकते हैं, लॉजिक पूछ सकते हैं, पूरा पूरा कोड्स नहीं पूछेंगे। मैक्सिमम कोड जो लिखवाएंगे वो फीफो का लिखवाएंगे, सिंक्रोनस वाले का। उससे ज्यादा या डी रैम का, एस रैम का, वो लिखवा सकते हैं मैक्सिमम टू मैक्सिमम, लेकिन उससे ज्यादा।
ये स्कोर बोर्ड और मॉनिटर एजेंट, इनका लॉजिक कैसे बताना है? लाइक इनका काम ही बताना है?
काम बताना है, और हाँ सेगमेंट्स का वो बताना है, काम बताना
और
होता है।
जैसे इनहेरिटेंस यूज हुआ है एक्सटेंड के थ्रू, और जैसे
हम्म
फंक्शन और बैक स्लैश यू यूज करके जो कमेंट होता है, जो कंपोनेंट ड्राइव करने के लिए, इतना ही तो बताना है ना?
एग्जैक्टली वो कोड एक्सप्लेन करना है आपको, बस जो भी आप लिखोगे उसको एक्सप्लेन करना है और करेक्ट होना चाहिए, है ना। वो आगे पीछे क्वेश्चंस होंगे लेकिन पूरा पूरा कोड नहीं लिख पाएंगे, है ना। तो वो है। और हाँ ठीक है, वो तो सही है। अभी अभी और किसी कमिंग इंटरव्यूज आर देयर? एनी कमिंग इंटरव्यूज?
मेगा सेमी ने मुझे बोल दिया कि ऑनलाइन नहीं हो पाएगा।
ऑनलाइन नहीं हो पाएगा, ठीक है। हाँ उनका था इंटरव्यू नहीं हो पाएगा, फाइनल राउंड हो पाएगा। और किसी कंपनी का?
और तो कुछ भी नहीं है, कुछ तो ऐसे रेफरल से भी अप्लाई करती हूँ तो नहीं आता है कॉल।
एसटी में अप्लाई कर सकते हो, क्योंकि एसटी और माइक्रोन में अप्लाई करो, क्योंकि ये लेआउट वाली प्रोफाइल में तो वो हो जाएगा शॉर्टलिस्ट
एसटी
आसानी से।
तो अप्लाई कर सकते हो, माइक्रो में तो माइक्रोचिप।
माइक्रोन।
माइक्रो, ठीक है।
माइक्रोन में भी हो जाएगा और एसटी में भी हो जाएगा, और एनएक्सपी, एनएक्सपी नहीं, इसमें एसटी, एसटी हो गया, माइक्रोन हो
डिजिटल
गया।
में ही जाना है।
हाँ।
सर ये नैंड और डोमिनोलॉजी, ये तो डिजिटल पे प्रोजेक्ट था ना?
लेकिन आपको और लाइक और ज्यादा प्रोजेक्ट लिखना है डिजिटल के थोड़े, है ना, लाइक उनका सब्स्टिट्यूशन ही है ना, अम्बा एसपीआई कम्युनिकेशन प्रोटोकॉल्स का, कम्युनिकेशन
मेरा
प्रोटोकॉल कर डाल।
AMP में एक और प्रोजेक्ट ऐड हो जाएगा रेडर सिस्टम का, जो मेरा कंप्लीट होगा तब ऐड होगा।
या राउटर भी डाल सकते हो, इट्स लाइक हमने भी काफी सारे प्रोजेक्ट्स करवा रखे हैं, यू कैन ऐड दोज प्रोजेक्ट्स आल्सो, राइट। और यू कैन मेक द टू प्रोजेक्ट्स लाइक टू रिज्यूम आल्सो इफ यू वांट, बट जैसे भी आपको सही लगे वो करो, लेकिन अभी डिजिटल वाले में तो और प्रोजेक्ट्स डालने पड़ेंगे आपको अभी, प्रोटोकॉल बेस्ड प्रोजेक्ट्स। ओके देन फाइन, थैंक यू, गुड नाइट। ओके बाय।